Welcome to the Cyclekart Symposium number 3. Chuck will be presenting to us about cyclekart wheels, specifically the hubs that he has built for his cyclekarts. If you have any questions or want more information, please leave a comment. Please don't forget to subscribe and like the video so that we can continue to make more of these. Thank you. All this great knowledge. I'm excited for this one. So, all right, it's all yours.
Okay, so I'll introduce myself first. I'm Chuck, and I live in Portland, Oregon, which is in the Pacific Northwest. I'm about 4 hours away from the race in Titan driving, right? And I'm about 4 hours from Slime Dog, and I'm about 12 hours, I guess, from Adam and the guys out in Salt Lake City, right? So I'm located pretty well as far as like making some of these events, which is the whole reason why I started building cyclekarts years ago, was that I had a neighbor that showed me what the races were like up in Titan, and I wanted to include myself in this. So I have 3 cyclekart projects kind of in progress, 2 that are running. If you're interested, they're on the Cyclekart forum. I post a lot of content on that forum, actually. I maybe overpost some, but they're all there. So there's a thread called Otis on the first cart that I built. There's a thread called Millie on the second cart I built, and there's a third thread called Opal, which is the one I'm currently building. So these photos that I'm going to show you today, I really pulled from that as well. So they're all there too. And you can probably, maybe there's more information in those threads than what I'll present here today, but that's my way of an introduction. And so these are the kind of things I'm going to touch on as I go through the presentation today. So first I'll quickly mention why I built wheels, right? You certainly don't have to build wheels to build a cyclekart. Everybody knows that. But I sort of get the feeling that a lot of people are having trouble finding wheels. So that's probably one reason why you might be interested in looking into this. And I hope this presentation is going to help you. At least you'll understand what you have to do in order to do it. My personal reason for building wheels for my cyclekarts is that I don't like looking for stuff. You know, like it never occurred to me even to try looking for Honda wheels, because that's not where my hobby is, right? Like my hobby is in the shop making stuff. And I'm not the kind of guy that gets up on Saturday morning and gets in his truck and goes out looking for stuff. You know, it's just not me. So I built my wheels personally because I just wanted to spend that time in the shop and not actually search for parts, which I do very little of, actually. The other reason why I built them is because I was really trying to build a lightweight cart, right? And so any effort I put into building a wheel lighter is going to be multiplied by 4 in the final cart, right? I mean, it really was a place to spend some time lightening the cart. This is a picture of Otis. Otis weighs 160 pounds wet, ready to go, right? With fuel and oil. So Otis is really light. And you'll notice that, you know, Otis uses bicycle tires, bicycle rims, bicycle spokes, right? It's one of the reasons why Otis is so light, but it's not the only reason why Otis is light. I took weight out of everything in the design, right? So the body is built light, the engine is built light, the torque converter is built light. The suspension is built light. The chassis is built light. Everything on Otis is built light. And I want to point that out because Otis's wheels kind of match the car. You know, if you're building a 300-pound cyclekart, it's probably not a good idea to use bicycle rims and bicycle spokes, right? So Otis gets away with using those kind of lightweight wheels because all of Otis is light, right? And the other reason why I built my own wheels is because it really also just let me tailor the design the way I wanted to, right? So these are the front hubs, and they have tapered roller bearings in them. I wanted to put tapered roller bearings in my front hubs, and I was able to do that because I built my own wheel, right? And also, I was using material that I can find around my workshop. You know, again, I don't like looking for stuff. So Otis's wheels came out of the scrap bin. And so it was kind of inexpensive to build them that way, right? And we can talk about this more. You guys will have questions and we can talk about it later if I don't cover it. But so let's look at Otis first. I actually built 2 sets of wheels for Otis. The first set was a failure. Okay, so this was my first try. At least one of the few pictures I can find of the first try. And can you guys see my little cursor? Yeah, okay, that's good. So the way I thought I would build Otis's hubs was I made these centers. And these centers, that's for the rear wheel. And the centers came out of bar stock, right? And the flanges, there's 1, 2, 3, 4, there's 4 shown there. So that's the rear. Those are flanges for the rear wheel. And I kind of set out thinking, well, I'll make this long tube in the middle. I'll make these flanges out of something kind of thick that probably was made out of 5/8 inch thick bar stock or so. And the reason why I did it was because I was going to weld all these parts together, right? So the flanges were going to weld to these center tubes. And I was going to cut a keyway for the rear wheels all the way across this center tube, right? So I did that. That's how I put Otis's first wheels together. Let me see if I have another slide. So this is what they ended up looking like in the end. This is one of the few pictures I have of them. The flanges are made from thick material and they're welded to these tubes. They were a failure because when I welded the flanges to the tubes, I forgot to clock the spoke holes the way they're supposed to be, right? So the spokes don't line up straight across each other, right? So like this spoke isn't straight across here. It's clocked half the division, right? And it's not that I didn't know that. It's that it's so easy when you're welding stuff to forget, right? So I screwed these wheels up by welding them together in a way that they weren't really going to work. I built the wheel up anyway, even though the spokes would have had to have been 2 different lengths in order to make it work because they weren't clocked. And I ended up pushing the wheel onto the axle that I had made without the keys. And I had made this bore here with a reamer, and it was super tight to the axle. It slid on, but once I had it on, I couldn't get the wheels back off the axle, right? So there were 2 mistakes I made when I made these wheels. One was I didn't clock the spoke flanges. And the other was I made this bore a little bit too tight to the axle. And probably because welding the parts together also made the temper go away in the aluminum, right? So it was no longer T6, it was a little softer. But when I went to take the wheels off the shafts, the axles, they were galled on. They didn't come off, right? So I was able to get one off with a puller, and the other one, I think I cut the spokes off the wheel because I had something else on there that prevented me from just pulling the spokes out. And I ended up cutting the hub off the axle. So that was a huge mistake right from the start. So when I made them the second time, I changed the design quite a bit. So this slide shows all the parts for Otis's front wheels and back wheels. And you can see I made the rear flanges like this with keyways in them, right? And I just used tubes to space the 2 apart, right? So the thinking here was the torque from the axle goes into the keyway, goes right into the part that the spoke flange is on, right? So that seemed like that would make the most sense. These here in the middle are the front axle or the front wheels, front hubs, and you can see they have a bore in them for the bearing race. This meant that there was quite a bit of work to do for the flanges, the 8 flanges, and the centers were just simple cut-off tubes, right? For a full set, you need only like half a foot of each, really. It's not a lot of metal. There were 2 different size tubes for the front and the rear. And I made sure to remember when I broached in the keyway that 2 of these are lined up with a spoke hole and 2 of them are half the division, right? So that when I press them together, they would be in the right spot. Now, it was my intention here too that I was not going to weld these together, that I was going to just glue these together with super glue. Okay. So this is a picture of how I made sure that my spoke flanges were clocked correctly. I just did it by eye. It's not that you have to spend a considerable amount of time making sure this is accurate. I put a spoke in a drill chuck and ran it down through one hole and made sure it fell halfway the distance between the other 2 spoke holes. Having a method for doing this was important, more or less, just to make sure I did do it right and not weld them together or glue them together in the wrong position. So that's how I did that. So then this is a wheel laced up. That's Otis's front wheel. That's what it looks like with a bicycle BMX rim, 20-inch bicycle BMX rim on it, 20-inch BMX tire, and spokes, bicycle spokes. So when I went to build Millie, I had a lot going on, really. There was a lot of stuff in Millie that I was more interested in than hubs. And there was a lot on Millie that I just wanted to make as quickly as possible and not spend any time with it. And I sort of remembered how much effort it was to make Otis's hubs. And I just figured for Millie, I needed something simpler to do. And that was actually really good because it turned out that I made a pretty simple design just because I didn't want to spend a lot of time on making Millie's hubs. And they came out a lot better than Otis's. And this shows you all of the parts that I used to make Millie's hubs. And this starts to be a little more easier to make, as you can see. So I've got 8 flanges here. They're all exactly the same. So the front hub flanges were the same as the rear hub flanges. The rear hub centers were made out of 2-inch diameter stock, and Millie's front hub centers were made out of 2-inch tubing, right? So the rears just have 3/4-inch bores through them in keyways, and the fronts just have a little short shoulder cut for the bearing race and a shoulder cut for the outside, so the flange sits on, similar to the rears do, right? So this was a much simpler design, and it's probably easier for people to do without any sort of machine tools. I'll show you in a sec here. So one other change I made to Millie was I decided I didn't need the keyway to go all the way across the center of the hub, right? So to make the keyway easier to make, I backboard the center of the hub. So when I was cutting the keyway in the hub, it was only cutting maybe about 1.5 inches or so, maybe even less. And then the space behind, I pressed in this bronze bushing to be 3/4 in the back. So you can see here's the center from one side with the keyway in, and the keyway doesn't go all the way through. The keyway only goes down about 1.25 inches or so maybe. And then this is the back side, which has the bushing pushed in. And I'm absolutely sure that these guys aren't going to gall on the axle either, right? Because the bronze bushing helps there. And then I probably left about maybe 5/1000 allowance or so between this bore and the axle, right? So that it wouldn't get stuck. And that's a picture of Millie's front hubs. And they're not welded. They're just glued together with super glue to keep them in place. And because Millie's front hubs are made from 2-inch diameter tubing, after I've bored for the bearing and made a shoulder for the flange, the tube was a little bit thin there. So I put this extra piece of tube over the top of it to give it a little more hoop strength. So that's why it has that kind of shape to it. This is Millie's wheel put together with bicycle spokes and bicycle hubs or bicycle rims. And because Millie's hub was a little wider this time than, say, a typical BMX hub would be, you can see if you look down here what happens to the spoke, right? Unlike on a motorcycle spoke, which stays pretty much straight. Millie spokes look like wires. You know, they kind of bend as you look down them, right? They sort of bend around the flange, and they bend where they cross, where they go into the rim. And this is completely normal for bicycle wheels, right? It's perfectly fine that way. But that's because of the fact that Millie's hubs are wider than BMX hubs. So the cart I'm working on now is Opal. And those hubs are a little, those hubs are a little bit different. They're again made out of these flanges that I make out of plate. So these smaller flanges are made out of 1/4 inch plate. The bigger flanges are made out of 1/2 inch plate. And they're built in the same way that Millie's hubs are built, in that the rear hubs are made from 2-inch diameter rod, and the front hubs are made out of 2-inch diameter tubing, right? So that's exactly the same, except actually, maybe I need to go back and show you this. So when I made Millie's hubs, I made all the flanges exactly the same with this large bore in the middle here, and which doesn't leave a lot of room on the rear hub for what I'm doing with the rear hub, where I'm pinning, in addition to the glue, I'm also running a couple of dowel pins into the face of the flange in order to take the torque, right? So even though I'm just gluing the flange to the center, I'm putting a couple of dowel pins in afterwards. And by making these flanges with a smaller bore, it gives me more of a face here in order to put those pins in, right? And so this is what they currently look like. They're on the cart, but I haven't built those up as wheels yet. So you can see what it looks like on the cart. There's the big, the large flange in the back. There's the 2-inch diameter stock in the middle, and then here's the outer flange, you know, for whatever. And this will just be all glued together and then pinned in the side. So if you're going to make hubs, you're going to need a lathe, pretty much, I would imagine. You don't need a very big lathe. It doesn't have to, it can be a rather small lathe, a little bench lathe. And also making the hub parts, I've found that you don't have to be so overly concerned with concentricity. You don't need to use a 4-jaw, you know, to make sure stuff is exactly concentric. You can definitely use a 3-jaw, because the spokes take up that kind of tolerance. You know, when you actually build the wheel, you can make the wheel turn concentric. So this is something I put together here to explain that to put the spoke holes in the flanges, you don't need a dividing head. You don't need a rotary table. You don't need to look up McMaster car tables for XY coordinates. You can probably do it just by eye. This is a hub set up on the drill press with a piece of cardstock paper, just to give you a little more accuracy for dividing the spoke holes, right? So you can definitely do it like that. You can also, you know, like Millie's hubs and Opal's hubs are made out of 1/4 inch plate. You can also send that out to a laser cutter, right? And have those parts laser cut if you wanted to make it easier. Here's a little tip I can let you guys in on is when I drill holes in hubs like this, I use short drill bits. I don't know if you guys have any short drill bits in your shop, but I have a full set of jobbers drill bits that I barely ever open up. I have like bins of these short drill bits that I use for everything. And so if I'm indexing a hub and I have to put 18 holes in it, 18 holes in it, I don't center punch. I don't center drill. I don't pilot drill. I just run the drill straight in because it's short and it doesn't flex, right? So this is a really, really handy thing to do. These drill bits, that's like a 4.2, that's a 5, that's a 6, that's an 1/8 inch, that's a step drill, that's a countersink. I have those on my shop bench all the time, and that's pretty much what I use to make practically everything, right? Here's a picture of countersinking the flanges, right? So you have to countersink both sides of your flanges, or your spoke holes. And that's for, well, I guess 3 reasons. The spoke has a little bit of a tapered head on it. So it helps the spoke sit really well in the flange. And then the other countersink on the other side is to not put so much pressure on the spoke bend, which is where the spoke always breaks, right? And then the third reason why you countersink both sides is because if you don't, you can't thread the spoke through the hub. You'll get it through, and when it comes to the bend, you won't be able to get the spoke to go all the way through the hole, right? So the countersink on both sides of the flanges are so that you can pass the spoke all the way through the hole when you do it. And this doesn't need any special kind of setup. You can just do it by hand, right? So that's just countersinking the holes in the flanges on the milling machine. Broaching a keyway. I have like 2 broaches, actually. This is like the biggest one I have. I use it for everything, 3/16. I bought it maybe decades ago. I don't know what it costs now. It's not very long. It's maybe only 6 inches long. But I use it to broach the holes in my hubs, right? It's one way you can do it. You just do it with a shop press. Another way you can do it is you can shape the keyway in your milling machine or your drill press, right? So this is a keyway that I had to cut that wasn't a broach size that I had, right? So this is a boring bar with a little piece of high-speed steel ground to the size of the keyway, and all I do is move the spindle up and down, right? So the spindle's locked out so it doesn't rotate, and I just move the quill up and down with the lever, right? So you take off very light cuts, maybe 2-3 thousandths at a time. It goes actually pretty quick, and you can shape a keyway if you don't have a broach, right? This is the cheaper way to do it. So lacing the wheel, I'm not going to go into much detail with this because there's lots of YouTube videos on how to lace bicycle wheels and how to lace motorcycle wheels, etc. But I'll show you the method that I always use, which is I always set the first 4 spokes first, right? And the first 4 spokes are the spokes that are by the air valve stem, right? When you set these first 4 spokes in, the hub is then in the correct position to the rim, and putting all the rest of the spokes in is a super simple, easy process. You can't make a mistake, right? And the other reason why you put the first 4 spokes in this way is because you want to make sure that where the valve stem lands, you have an open space for your hand and your air pump chuck, because if it's off there, you'll find that you won't be able to put air in the tire, right? So lacing the wheel, you kind of set this spoke in first. You count around the hub. Depends on how many spokes you have in the wheel. Numbers, like I think 11 for 36. You put this spoke in, right? And it's the opposite of the way this one went in. Then on the other flange, you put these 2 in, and then that sets up your pattern for building the wheel. And if you find this method online on YouTube explaining it, it's one of the easiest ways to build a wheel and not make a mistake. With Opal spokes, I can't get spoke lengths. I can't buy them the way in the length I need. But I have this little tool here that I've had for a couple of decades too, and it's a thread roller for spokes, right? And it's a replacement head for a bicycle tool that I don't actually have. I didn't buy the bicycle tool. I just bought the replacement head, and I think maybe 20 years ago it cost like $30 or something. But it will roll the threads on the end of spokes. So you can buy spokes that are longer than you need. You can cut them, and then you can roll them on. You can't die cut spoke threads. If you were wondering, you have to roll them on because the diameter of the spoke isn't big enough for you to die cut the ends on. I use this in the lathe. So I put the thread roller in the tailstock, and I have a little drill chuck that has a hollow arbor so I can hold a spoke in it, and I can run threads on the end of the spokes. So If you can't find spokes, the length that you need, you can certainly have like a shop cut them for you and make them for you, or you can do it yourself with a tool like this, right? You'll also have to set up some way of truing the wheel. My wheels are small enough that I can just put them in a bicycle truing stand. That works pretty well. And if you guys have any questions about truing wheels, I can certainly go into more detail with that in questions as well, right? So tensioning. I pretty much tension my wheels pretty darn tight, and I typically don't measure the tension, but I have borrowed a tool like this from a friend in order to do that. And this kind of tool will help you sort of make sure that your spokes are all close to the right tension, but you're not looking for them to be exactly the same. In fact, you'll never will get them exactly the same. I think plus or minus 20% is like fine, really. But you do want to make sure that some of your spokes aren't a little bit loose and some of them aren't a little bit over tight. And a tool like this will help you do it. I think there's actually maybe an app you can download on your phone that you can probably use to measure the tension in your spokes just by plucking them, and it'll listen to the sound and tell you what the tension is. But I don't really know. I just think you can. So this is a picture of Otis's wheels after I dropped the chain and jammed the chain down between the spokes and the sprocket. And you can see what the chain did to the sprocket, and you can see what the chain did to the spokes, right? I mean, it bent the spokes. They're stainless steel spokes, and it kind of cut some of them nearly in half. But the cart still drove around the track perfectly fine. None of them broke. This is more than likely because the spokes are stainless steel, right? And they're not old 60-year-old nickel-plated steel spokes, right? So spokes that are stainless steel, like if you end up replacing your Honda spokes with stainless steel spokes from Buchanan, or bicycle spokes that are stainless steel, they're particularly good at what they do. And that was the damage that dropping a chain down between the sprocket and the spokes did, and it still held together. This was the repair. After I fixed everything and replaced the spokes, I ended up putting these plastic chain guides on the chain so it couldn't do it again, right? So it's something to consider to protect your spokes that way. So I'll also mention the axles briefly, because making your own hubs don't require you to have any sort of adapter, right? So it opens up the possibilities of axles being made a little easier. This is Opal's front axle. It's just 3/4 inch steel bar stock that's welded into the king arm, the kingpin pivot here. And the way I end up adjusting these tapered roller bearings is I assemble the bearings and the wheel on the axle. And then what I do is they're held on with a bolt here, and I put a washer there, and then I put little shimming washers in order to adjust the load on the tapered roller bearings. This way, I don't have, say, like a lock nut on it. I don't have to set that bearing and then adjust the lock nut and then tighten it down so it doesn't move. I basically could torque this bolt down as hard as I want, and little shim washers will keep everything spaced so that I get spacing for the bearings. I do the same thing with the kingpin, by the way. You know, they're like these little shimming washers. They're probably like maybe 0.003 of an inch thick or so. I can just put as many in as I need to make sure that is tight but not too tight, right? So I think in the end it ends up like I've got 2 shims on one side and I've got 1 shim on another, and you know, you get the picture. It's like it's just something you have to write on the axle or the wheel to make sure you put it back together the right way so the bearings are set up right. That shows you a little, you know, again, the little washer and the bolt that holds the wheels on. When a little shimming washer could fit between this washer and the bearing race, and that's how I adjust my load on my bearings. And then the rear axles, I made all 3 rear axles with hollow tubing, right? So it's chromoly tubing. And I press in a 3/4 inch shaft for the wheel axle to sit on. And I then just cross drill it and put in a roll pin, right? So I don't weld those together. So my axles are hollow, they're light. They have 3/4 inch shafting for the wheels. And that's how I make them, right? So they're just roll pinned together. They're not welded. I think that might be all I have, guys. So